Hey everybody, welcome back to lab number 3. I hope you guys had a great Ramadan and a good Eid break, which is still going on. But I am going to put this experiment online. This is Wednesday the 27th, and this won't be have to be handed in until next week. But yeah, I hope you guys had a good holiday. So this lab today, you can see I'm in kind of a new angle here. I'm at my stove top, and we're going to look at today temperature and its effect on dissolved oxygen, carbon dioxide, and since I have this all set up, we will also look at pH. In the class on Tuesday, next week, so this will be just before your lab is due, we will talk about carbon dioxide and pH, but this is all in your notes and it's pretty straightforward. We did talk about this earlier in the chapter. So quick cut here, I'll kind of set a few things up and we will get started. Okay, so part 1 of this is let's talk about the equipment before we do the experiment. So the equipment that I have, again, I mentioned we're going to monitor or test temperature and its effect on dissolved oxygen, carbon dioxide, and pH. So the equipment. I'm obviously not in the lab. I don't have beakers and hot plates, but I have a saucepan and my stove, which you might not be able to see. The stove is just a giant hot plate, so there's not much different here. This has been cleaned, and the water I'm using inside is just tap water. I'm not going to do all of these experiments with tap and bottled. We already tested the difference with dissolved oxygen. So just so this video isn't an hour long, I'm just going to test tap water today. So in my saucepan with the tap water that I have cooled to room temperature, I have 2 clips. In one of the clips is a temperature probe, and in the other clip I will put a pH probe. Now I'm not going to move my setup, but the temperature probe is a cooking probe, barbecue or grilling probe I got years ago as a gift, and it's amazing for me anyways. It links to my phone. So you can see, and I know it's a little backwards here, but the temperature is 22 degrees Celsius. It was actually 21 when I started the video, so it's warming up a little bit as I'm filming. The air conditioners are off, so it's warming up, but that's the point of this lab. We're going to test this at different temperatures. Another cool feature that I might use in the experiment is the graph. This also graphs the temperature, and you can see it's mostly a straight line and a little bump up there to 22 at the end. So it's been at 21 for a few minutes, and it's, again, air conditioners are off, it's slowly rising, but not an issue because we're going to turn the oven on shortly. I'm going to test dissolved oxygen at 20, 40, and 60 degrees. That's our 3 temperature parameters for today. I'm going to test carbon dioxide, and I will show you this test today. Very quick experiment or test. I won't bother showing you the dissolved oxygen again. We saw that last week, or last lab. And the last piece of equipment is a pH probe, a portable pH probe, which I calibrated this morning. Should be pretty good, pretty accurate. So, saucepan water with temperature probe. I have a clip for my pH probe, 2 test kits, and we're ready to go. I guess part 2 of this lab before I do the experiment is very quickly the theory, or a review or a rundown of the theory. We've already talked about in class dissolved oxygen and a little bit about temperature. So anything that I'm talking about today that you haven't done in class, we will do Tuesday in class before the lab is due. So temperature. Temperature is one of the most important parameters, I guess, or physical properties of water because of how it affects so many other properties. We learned about density, dissolved oxygen, carbon dioxide, pH, total dissolved solids. I mean, there's so much that temperature influences, and today we're going to look at 3. Just a review, and you guys learned this back in chemistry, I'd say 1200. We know that as the temperature of a solution increases, the solubility of a gas decreases. And the reason we can kind of talk about kinetic molecular theory, again, this is all back from 1200, as the temperature in here increases, remember temperature is just a measure of the kinetic energy, the speed of the molecules in this. So when the temperature increases, the particles move a little faster and faster and faster, but that means the gases that are dissolved in this, there is definitely oxygen and maybe CO2 in here, they become faster as well. And they can escape the water. The solubility, like I said, decreases. So we should see the parts per million, we should go down. Now that's the theory. We're going to actually do the experiment and see if it's true. So temperature increases, solubility of gas decreases. Now pH, this is a little more complicated. We know that carbon dioxide is acidic. We talked a little bit about that a few weeks ago. So as the carbon dioxide leaves the water, you would assume it might become less acidic, but there's more to this pH concept than just the carbon dioxide in the water. This is actually related to Le Chatelier's principle and equilibrium, which you did, I guess, again, back in maybe 1201, 1210. We will review this in class if you have any questions about this. But the idea is, as temperature changes in here, it will change the equilibrium. The equilibrium in this is between water and its ions, hydronium, H3O plus, and hydroxide, OH minus. So as the temperature increases or decreases, the equilibrium shifts and it changes the ion concentrations in here. So pure water should be 7, H2O, but there's ions in here that the pH probe will measure. And we're going to monitor this shift and see what happens to the pH. We will talk more about this in class, but it'll be an interesting experiment to monitor the pH as the temperature increases. Okay, so I'll be right back. I'm going to do a quick little demo and then we'll get started with the actual heating and testing. I have a very quick demo for you with 2 different samples of water here. I'm kind of covering them up a little bit because one of these samples of water is carbonated water, full of CO2. So one is from the tap, and I've let them both come to room temperature, and the other is from this can, Everest. Again, no sponsor. But this is sparkling water full of carbon dioxide. They put the carbon dioxide in here, so it's fizzy. Okay, you can kind of hear it fizzing there. And we know chemically carbon dioxide is an acid, and when it's in water, it reacts to form carbonic acid, so it should lower the pH. We talked about this in class, all the problems this can have for something like the ocean, where the atmospheric CO2, as it's increasing, it's also increasing in the oceans because it's dissolving or diffusing into the water. As the waters become more acidic, it can harm the aquatic life in there who have a certain pH range they need. It's affected the coral reefs and things like that. So it's an interesting concept about the CO2 in the atmosphere and its effect on ocean systems. So very quickly, and this is almost a test for my pH probe as well, I'm going to put the pH probe into 2 of these samples. I'll keep them hidden. And I'm going to see if, or ask you guys to tell me which one is the sparkling water in the D2L quiz. Very, I guess, kind of simple question. And again, it's almost a test to see if the probe is working well. I did calibrate it this morning, like I said. There will be a few quick cuts here because the probe takes a few minutes. It's not the best to kind of settle. So I'll start with one of these. We'll call it A, and I'll be right back. I've let this kind of settle for a minute. We'll call this sample A, You can see the little bottle here. And the pH of this is kind of jumping around the same number a little bit. 7.65 is the pH of this sample. So this is sample A, 7.65. Let's try the other one. Sample B, I've let it kind of settle a little bit, and the number here is 5.31, 5.30. It's moving a little bit, but the pH is significantly lower in sample B. So with that information, you should be able to tell very easily which one of these is carbonated water and which one of these is just tap water. And the difference is amazing. The difference in pH of about 2, just because one is tap and one is from, you know, a can of sparkling. Cool. Okay, so the next thing I'll do, we'll test the carbon dioxide using this test kit of the room temperature water, which is 22 degrees still, and then I'll heat it up to 40 and 60. I think I'll only show you one more, maybe at 40. Okay, so let me get this the experiment set up, and there's just 2 quick parts left. We're ready to do the first experiment, first test with the room temperature water. It's still 22 degrees Celsius. I do have the pH probe in here, which I will monitor as we go through, and I'm going to show you now the experiment for the carbon dioxide test kit, not the dissolved oxygen. We did that last week, so I'll do this off camera. So carbon dioxide test kit, very easy instructions. It's 4 steps. I'll go over the chemicals and then we'll get the experiment started. So there's only 2 chemicals here today. There is, or 2 reagents, I should say. There's Phenolphthalein Indicator, which you guys might remember from your titration lab. It's an indicator that is clear and colorless in acid, and it's kind of bright pink purpley in base. So based on the pH or the amount of acid in this sample, we can find the parts per million of the carbon dioxide. So we're going to add the indicator, and then we're going to add this sodium hydroxide reagent. This is just a straight up mini titration to try and find the amount of CO2 in this. Again, it's just like a regular acid-based titration. Our titrator today will tell us the parts per million of CO2. It looks the same as the syringe from the last lab, but it's different. It has different subdivisions on it. So this is specific to this kit. It's completely different than this one. This is, again, they look the same, but the readings are nothing alike. So after I get this set up ready, we'll do the titration. So here we go. All right, so I've taken in this sample, they call it a test tube, but I've taken this and filled it to the line, the 20 centimeter line with this water here. I have this cleaned out, and the second step after filling this up is to add 2 drops of the phenolphthalein indicator. It mentions in the lab procedure here, when you're doing this, say in an aquarium or a water source, you do this quickly. Unlike the the dissolved oxygen kit, we can't lock this in. We can't lock the CO2 in like we lock the oxygen in. And I'll talk a little bit about that in the next part of this video. So this part I have to do pretty quick. I can't waste too much time here. So let's get going. I'm going to add 2 drops of the indicator into this. Now it says if it turns pink right away, there is no CO2 present. That means it's basic, it's not acidic, it would be pink because of the indicator, and we're done. There's no CO2. So let's see, there's 2 drops. 1, 2, put it back here. It did not turn pink at all. Okay, so I'm going to put the cap on, and I'm going to fill the titrator with the solution here. Again, this is just base sodium hydroxide. We're trying to measure the acid in this by titrating with a base. Stoichiometry straight from your chemistry lab in 1200, just different equipment. With this same thing, stick it in. I'm going to put some gloves on for this because it is sodium hydroxide. It's very weak. It's only a 1% solution, but still be a little safe with my hands and get this filled up to the mark. Gloves on. Do this really tight, make sure there's no air bubbles in here. I found it's actually works for me a lot better if I pull this a little quickly. So I'm going to turn it upside down. I'm keeping this syringe firm into the top here, and I'm trying to get no air bubbles. I will fill it to the 0 line on the top of this. So I turn it vertical, and I hope for no air bubbles. Looking good. Okay, we are ready to go. So this is a little hard to see when I do this titration. I might use this as a background to see when it turns pink. It's a bit bright here, but here we go. I'm going to add this drop by drop into this solution until it turns and stays pink for, I think this says 20 seconds, but just like the lab, we want this to stay pink, not changing. So if I put a drop in here, just one drop, I don't know if you can see that. I'll do one more because I don't think it's ready to go. You can see some of that purple color mixing in, pink or purple. Now, when I shake it, it's gone. It vanished. So I'm going to keep doing drop by drop until this stays a very, very light pink. Okay, guys, this is, it might be really, really hard to see on the camera, but this is the lightest shade of pink. I will just do another drop or two just so you can see, but it's definitely not clear colorless anymore. You can really see with this white background here, it's just the lightest shade of pink. So I'm done my titration. Now, that amount, when I look at this, it says here each subdivision equals 1. That's really easy. So you can kind of see the plunger here. The number of this is exactly 16 ppm on this line. So 16 parts per million in this sample of water. They say, normal surface water can be between 0 and 10. Groundwater can be a lot different. So I had about 15 ppm here at still 22 degrees Celsius. Now, again, very light pink. If I added the rest of this, you can see this is way too much. This is not what I'm going for. Okay, that light pink is what I'm going to try to get in all of my titrations. I'm going to do one more off camera. I think I might have added an extra drop. So I'll do one more and then we'll start heating this up. Okay, and I'm just going to do on camera the 40, and that's it for this experiment. I should mention before I turn this on and heat it up, it's still at 22 degrees Celsius. Okay, I'm going to turn the oven on in a minute, but I wanted to get the pH reading at 22, and this is holding steady at about 7.23, sorry. Off camera, I just stirred this around. You want to make sure, I want to make sure as I'm heating this, I'm stirring it around. There's no stir bar in here. So it's 7.22, 7.23 at 22 degrees Celsius. So I'll stop the video here and I'll be back at around 40. Okay, quick little interruption here. This is at 37 degrees Celsius. I have this at the lowest setting. It's slowly coming up to temperature. I don't want to blow by 40 because it can really affect my results. And I want to talk about my results really quickly here. There's an issue, or could be an issue, with this experiment. The dissolved oxygen test kit through chemical reactions and stoichiometry, completely locks in the O2 by converting it into another chemical that we titrate. So when I get my water solution at 40 and lock it in and set it up so my O2 is converted into another chemical, the temperature fluctuations of that sample shouldn't matter. I have the O2 converted, it's ready to go, I can take my time. The CO2 test kit doesn't have that luxury. It's just a straight acid-based titration with phenolphthalein. So I have to do that experiment really, really quick. I'm going to do 2 samples. So when this hits 40, I will, as quickly as possible, do those 2 titrations. But again, as this sits here and the temperature changes, I don't have the ability to lock in the CO2. So there is a small issue there and I have to be really quick. So this is at 39. I'm going to get my gloves on and get set up. Okay, we are at 40 degrees Celsius. You can see the graph there slowly rising. You can see my temperature at 40 degrees Celsius. My pH, I'm going to record that it has dropped to 7.04 at 40 degrees Celsius. I have my 20 milliliters collected here, so I'm very quickly going to get this titration done, show you the results, and that's it. Well, I'm ready to go here. I have this titrator filled. I'm very quickly going to add the 2 drops of phenolphthalein indicator in here. Remember, if this turns pink right away, there is no CO2 present, free CO2. So 2 drops, 1, 2. Again, I didn't see any color change here. It's still clear colorless. So let's get going with the titration. Okay, so guys, I think I'm pretty much there at the end point. I know it's really light, but you can tell it's not quite clear and colorless anymore. It has the lightest shade of pink in here. Okay, it's a little easier to see without the camera, but it is definitely the lightest shade of pink. So I'm going to read the parts per million here. Okay, so this one's a little bit more difficult to read. It's actually around 13. I know you can't see this, not very clearly, but it's actually in between the 13 and 14 ppm mark. So this is around 13.5. Okay, again, it looks so much more pink than it does on the camera here, but it's definitely a very light shade of pink. So around 40 degrees Celsius, we had 13.5 ppm. I'll do it very quickly one more time. Heat it up to 60 off camera, and I mean, that's it for this experiment. So I hope you guys enjoyed that video, or this video. The questions will be online on the D2L quiz, and as always, if you have any problems, issues, questions, you can send me an email, we can chat or have a Zoom meeting, something like that. Okay, I'll see you guys next week in class. Have a great rest of your Eid break. Bye-bye. Hey guys, back with a little after credits scene. I'm at 62, it was just 61, and the pH meter here is 6.89, 6.88, so it has 6.89. It's dropped at 62 degrees Celsius. So do the other experiments, and that's it. Okay, bye-bye.